We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello everyone, today I like to discuss about the topic of speed time curve of electric traction system. As the name indicates, it is the graphical representation between the speed and time. Through this curve, we can see that with the variation of time, what's the effect of speed. So here speed is dependent on time, so we take independent quantity, that is time, on x-axis and dependent quantity, that is speed, on y-axis. Here the time is in second and the speed is kilometer per hour. So first we discuss about the generalized speed time curve, then we discuss about the trapezoidal curve for main line services and quadrilateral curve for urban and suburban services. This is the generalized speed time curve. Suppose the train starts from one station, that is O, then it accelerates from some time, then it reaches the maximum speed, that is B, then B to C it continues to run, then it retards and finally it brakes and it stops to the another station. Okay, suppose we consider one non-stop train from Valsad to Surat. So here O is the station, one station, that is Valsad, and E is the another station, that is Surat. We consider the one non-stop train. Suppose for example we can take Secunderabad Express. So it starts one station, that is O. Here we consider Valsad. Then it starts from Valsad. Then it constant acceleration period arises. Suppose A is the Bilimora station. Then it continues to accelerate. Suppose B is Amalsar station. Then it reaches to NAVSARI, then Maroli. Then C, suppose we consider the Sachin station. So from Amalsar to Sachin, the period is known as free running because it runs to the maximum speed. Then train goes to in costing period. So see, we can consider the Sachin, then Sachin to Udna, the costing period arises, then Udna to Surat, that is braking period. This curve consists the following parts. First, notching up or constant acceleration period. Second, A to B, that is acceleration period. B to C, free running period. C to D, costing period, and D to E, braking period. We can understand one by one. Now start first notching up or constant acceleration period. During this period, starting resistance is being cut out. So it accelerates from one notch to another notch. So it is also called as notching up period. The average tractive effort and the current remains constant. So acceleration also remains constant. So it is also called as constant acceleration period. Okay, the speed is gradually increases in this period, and so we can draw the straight line during the period O to A and time period O to T1. Okay. Next is acceleration period. After starting resistance has been cut out at point T1, okay, the means when starting operation is over, train still continues to accelerate along the curve AB. During this period, the motor current and torque decreases as the speed increases. Why? In accordance with the speed torque characteristic of the motor. We can use generally DC series motor in the traction system. Okay. So acceleration gradually decreases till torque developed by motor exactly balanced due to resistance of train motion. Okay. So in this period the torque is gradually decreases and current also decreases and the speed is increases. Next, our third is free running period. Now we can see that at the end of second period, means at T2, train attains the maximum speed. Here in the also graph we can see that B is the maximum speed of the run. During this period, train continues to run at constant speed. So current, torque and power drawn is also constant in this period. One question is arise that in which period the speed, current and torque, also power remains constant. So the answer is free running period. Okay. Next is costing period. So at the end of third period, power supply is cut off and train allowed to run under its own momentum. So speed of train gradually falls due to train resistance. So during this period, what happens? Current, torque and power is 0. So the speed gradually decreases and train runs without any input power. Okay, so it runs based on the kinetic energy. This period is necessary since it utilizes some of the kinetic energy of the train. Otherwise, it is wasted during braking. So it helps to reduce the energy consumption of train. So one question is arise, in which period, okay, the train power supply is cut off and train run under its own momentum, or also as maybe the current, torque, power is almost 0, in which period? So answer is our costing period. Last, braking. Braking T4 to T5. At the end of costing, during this period, brakes are applied, okay, and train is finally stopped. So we can see all the periods and train runs from O, that is one station, to E, that is another station, okay, and during run these 5 basic operations are done. Now we can see the terms related to the speed time curve. First, crash speed. Okay, so what is crash speed or maximum speed? So it is the maximum speed attained by train during run is known as crash speed. It is denoted by Vm and measured in km/h. Here in the graph, point B attains the maximum speed or crash speed. Okay. Next is average speed. So it is the mean speed maintained by a train during run. It is denoted by Va and measured in km/h. Average speed Va is equal to distance between stops or station in kilometer upon actual time of run in hour. So this is the equation of average speed which is useful in the example. Next is schedule speed. So what is schedule speed? It is the ratio of distance between two stops and total time of run including stoppage time is known as schedule speed. It is denoted by Vs and also measured in kilometer per hour. So schedule speed Vs is equal to distance between stops in kilometer upon actual time of run plus stop time. Okay, so see the difference. In average speed equation, distance between numerator is same but denominator is different. So both in numerator distance between stop or station in kilometer and average speed upon we can only consider the actual time of run, but in schedule speed we can also consider the stoppage time. So the equation of schedule speed is equal to distance between stops upon actual time of run plus stop time. Okay, now we can see the different services comparison. So this is the parameters of comparison for urban service, suburban service and mainline services. Okay, first is distance between station. For urban services it is 1 kilometer, suburban services it is 2 to 8 kilometer, and for mainline service greater than 10 kilometer. Okay, maximum speed in kilometer per hour is near about 110 in urban, 120 suburban and 160 mainline services. Next, acceleration in kilometer per hour per second. So that is urban services 1.5 to 4, same as suburban 1.5 to 4 and mainline services 0.6 to 0.8. Next, retardation or braking retardation is also unit is kilometer per hour per second. Urban service 3 to 4, suburban same and mainline 1.5. Now speed time curve, we can see that no free running period because stoppages are more. Okay, and costing period is small. We can see in this graph. And for suburban services, no free running period because stops are also more and costing period is long compared to this urban services. Okay, next is long free running period in for mainline services and also costing period is more because the stops are less in the mainline services. We can see the speed time curve for the mainline services. For example, we can take metro trains for urban services, local trains for suburban services, and for mainline services we can consider the long route trains. Okay, so this is the comparison for urban service, suburban service and mainline service. In the next lecture we can see the trapezoidal speed time curve for mainline services and quadrilateral curve for urban and suburban services in detail. Thank you.